6.4, number 59, we want to find this indefinite integral for number 59. And integration is a recognition type of problem. You look at the integrand to begin with, and you're thinking, what can I do here? What integration rules have I learned that I might be able to apply in this problem? So one thing that you might notice here is that you have a power here. You have 1 minus e to the 4x raised to the 100th power. So maybe you think I can use the power rule for integration, but not as the problem is currently given. You would have to do a u-substitution. So here's a quick review of the power rule for integration. If you have x squared for your integrand, what would be your antiderivative? All you do is you add 1 to the exponent and divide by the new exponent, and you have your constant of integration. And here is the general version of that power rule for integration to be used along with the u-substitution. So that's what we're going to do. We're going to go ahead and apply the power rule for integration, but we have to do a u-substitution. So you would like to let u be equal to the function that you have for the base. But will it work out? We have to see. It will work out if we're able to change variables so that we will have everything in terms of u, and then we'll be able to apply the power rule for integration. Will we be able to change variables? To answer that question, we'll have to go step by step. So we begin by letting u be equal to the base in this power. Let u be equal to 1 minus e to the 4x. The next step that you have to do is find the differential of u, du. And this will help us to determine if we're able to change variables or not. So how do you find du? To find du, you're going to take the derivative of 1 minus e to the 4x and multiply by dx. So the derivative of 1 minus e to the 4x, the derivative of 1 is 0, and then you have minus the derivative of e to the 4x, so you have minus the derivative of e to the 4x. You have to use the chain rule because 4x is your inside function. So the derivative of e to the x is just e to the x, so we have e to the 4x multiplied by the derivative of 4x, which is 4. So now we have the derivative of 1 minus e to the 4x, and then you multiply that by dx, because that's the definition of a differential. So here's what we have. du is equal to negative 4 times e to the 4x dx. And what you should observe is that here I have e to the 4x dx, and in the original problem I also have e to the 4x dx. So now you can isolate e to the 4x dx by multiplying both sides of the equation by negative 1/4. When you do that on the right side, you'll just be left with e to the 4x dx, and on the left side you'll have negative 1/4 times du. So this is our u-substitution. And now we're going to see if we can do our change of variables step. This is when we find out if our u-substitution works. Are we able to rewrite our original problem so that everything is in terms of u? Let's find out. So we're going to replace the base with u, and then we have u to the 100th. And then what do we replace e to the 4x dx with? It'll be replaced with negative 1/4 du. So yes, we were able to change variables from x to u, so this substitution has worked out for us. Now let's complete the problem. So now we're going to use our power rule for integration, and before you use that, you can factor out the constant factor of negative 1/4, and now we have the indefinite integral of u to the 100th power du. So we have the negative 1/4, and using the power rule for integration, all we do is we look at the exponent that we have in the integrand, and we add 1 to it and divide by the new exponent. So The exponent that we have in the integrand is 100, so we add 1 to it, we get 101, divide by 101, and then we have plus c. To complete the problem, you should go back to the original variable that we had in the problem, which was x. So how do we do that? Just go back to your substitution. U is 1 minus e to the 4x. So where you see u, you're going to replace that with 1 minus e to the 4x. And here's our final answer. That's one way in which you can write it. If you wanted to multiply the negative 1/4 to 1 over 101, you could do that as well. And that would give you an alternative form of the answer.